Now we are going to be working on case 4 on our vector resolution of vector, finding our resultant vector. And the fourth case is when the two vectors are acting on the body at acute angle to each other. Now the angle between the two vectors is less than 90 degrees. Now this is a typical case of that. So we have this. So let's still use that 40 Newton case that we used before. And then remember, this is supposed to be 90 degrees. This is supposed to be 90 degrees. But in this special case, the vectors are less than 90 degrees to each other. So let's assume the angle between them, instead of being 90 degrees, is let's say is 30 degrees, because actually 90 degrees, 30 degrees is less than 90 degrees. So we have here also as 30 Newton. So we have this. Now how do we resolve this? The same two methods of resolving case 3 is what we're going to be using here, both the scale method and the analytical method. So let's focus on the scale method first with the same parallelogram law of vectors. If you want to get that, go straight to case 3. We have stated our parallelogram law of vectors there. So let us see how we can use scale method to solve this. By scale method, we have to choose a scale in the both. So we have, let 1 cm be equal to 10 Newton. So if 1 cm is 10 Newton, it means you are saying this is 3 cm, this is also 4 centimeters. So we go. Now let us try to resolve this. So as usual, draw a line here, a straight line with your ruler here, a very straight line. Then come here, mark out points here. On this point you mark out, put the middle of your protractor there. Then from here, take your 0, mark out 30 degrees, should be somewhere around here. So mark it out. So at that point where you mark out your 30 degrees, draw a line from this point to join that point to mark out 30 degrees and draw it up. So you have your 30 degrees here as an angle drawn to scale. Then on this line, mark out 3 centimeters. Then mark out here your 4 centimeters. With your ruler, mark out your 4 centimeters. So at this point, you have marked all this out. Go back to this point again. Put your protractor here. So while you put your protractor here as well, from here, take your 0 to 30 degrees will be somewhere around this point as well. Also follow it. Yes, draw a line like this to meet up with 30 degrees. And then from here, mark out your 3 centimeters as well. So you mark out your 3 centimeters here. Okay, so at that point, join this to this. So now you have formed a parallelogram. You can see it, well drawn to scale. Then from here, draw your line, which is your diagonal now, to meet with the common point. Don't forget to put your arrow here. Then you have your arrow here. Now all you need to do is measure this place. Whatever you get here is the value of your arrow. So let's assume at the end of the day, your arrow will be 7 centimeters. If it's 7 centimeters, then arrow now will be equal to 7 times 10, which is equal to 70 Newton. So that is that for that. So you've gotten that. Then to find your direction of action, which is the direction of this, just put this like this. This is your direction, alpha. So just come back here, put your protractor back at the point, its position. Then from here, which is 0 mark of the protractor, read the angle where this line, this resultant line, meets with the angle. Read what angle is on this line. Whatever it is becomes your alpha. So let's assume at the end of the day, that place is that place might just be 12 degrees or 13 degrees. So that becomes your direction of the resultant vector. All right, so having done the scale method, this is the scale method, let's look at the analytical method. So your analytical method, let's see how you can solve that. Now you remember you have 30 degrees here, and this is 30 Newton, this is 40 Newton vector. So you have this. Now let us complete the task by doing it this way. Yes, so to complete, now you cannot use, because this is not a, okay, so this is your resultant vector. Now remember, we have this one divided into two, so you pick one right angle, you pick one triangle, because this is not a right angle triangle actually. So you pick one triangle. So let's pick one triangle. We have this. So this is what I am actually picking. So we have this. Okay. So yes. Well. Okay, so this is your 40 Newton and this is your 30 Newton. Here actually is your 30 degrees. Don't forget that. This place is not your 30 degrees. Okay, so this place is not your 30 degrees. This place is your 30 degrees. Okay. Now let us see. This is our resultant vector. We have to find the resultant vector. Now, this case, you don't use Pythagoras theorem to find your resultant vector. Why? Because this is not a right angle triangle. So you use the cosine formula, or you call it cosine rule. So use your cosine rule to work on this instead of using Pythagoras theorem. But before you use your cosine rule, remember this is your direction. Okay, remember we have to find what angle is this point. So if this is 30 degrees and the whole of this is 180, so this place will be, if the whole of them is 180, this will be 150 degrees. Yeah, that place will be 150 degrees. And if that place is 150 degrees, that is the angle you should be using. All right, so let us see what we can do. 150 degrees. So you come, your cosine rule states that r squared is equal to f1 squared plus f2 squared minus 2f1 f2 cos theta. So if we compare this with what we have in the diagram, that will give us, remember we are looking for r squared. F1 can be likened to one of the vectors. So we have f1, which is 40 squared plus 30 squared minus 2 times 40 times 30 cos 150 degrees. So that gives us r squared is equal to that will give us 1600 plus 900 minus 2400, then times cos 150 is minus 0.8660. So we have that. So this 2078.4 times plus 2500. So that will give us r is equal to, that will give us 4578.4. So that's r squared. So r now will be equal to the square root of 4578.4, 67.7 Newton. Next, we do what's it called? Our direction. Remember, if we find the resultant first, we must also find the direction. So our direction cannot be gotten using normal trig ratio, but we can get it using sine rule. So our sine rule states that a over sine A is equal to b over sine B is equal to c over sine C. Here A is the line, big A is the angle, small b is the line, big B is the angle, small c is the line, small c is, big C is the angle. Now we can't use these three at the same time, so we can only use two parameters at the same time. So let's compare this with what we have here. So if we are using, we always use the angle and the line opposite the angle. Then the angle here, the line opposite the angle. We have two angles in question here, 150 degrees. Opposite it is arrow, that's the line. Then alpha, opposite is 30 Newton. But remember, we are looking for alpha. So let's use these two instead. So we have A, we can say A is r all over what is the angle opposite arrow, 150. So we have sine 150 degrees is equal to B, let's use it as 30 Newton all over sine B is sine alpha. So we are using that, that's angle opposite that line. So we can cross multiply at this point. So if we cross multiply, remember we have the value of r already calculated as 67.7 Newton. So we have 67.7 sine alpha is equal to 30 sine 150 degrees. So let's solve. That will give us sine alpha is equal to 30 sine 150 degrees all over 67.7. So that gives us 15 all over 67.7. So sine alpha is equal to 15 over 67.7. That will give us 0.2216. So alpha is sine inverse of 0.2216. That gives us 12.8 degrees. So this is the direction of the resultant force, and this is our resultant force. So this is how we can work on the case 4. Please don't forget to subscribe to our YouTube channel if you enjoyed this lesson.